Okay, folks, this episode may hurt your brains a bit. It definitely broke mine. Today's guest wants to build AIs that understand pain and suffering. Why? Because he thinks if they do, then they might stay aligned with us feeble humans when they become superintelligent. Daniel Hulme wants to build AIs that can protect us from AI.
It's like an antivirus for, I mean, it's hard to talk about this stuff out loud because it sounds crazy. It sounds like it's something from Marvel, but that's where we're at.
Daniel sold his last AI company, Satalia, to WPP, where he serves as chief AI officer. And he's just founded Conscium, which verifies that AI agents are safe and that they can do what they say they can do. Conscium is also researching consciousness and pain because not only does Daniel want humanity not to suffer, he also wants to prevent AIs themselves from feeling pain.
There's a concept called mind crime, which is that we could build agents that are conscious and not realize that we're putting them in horrific situations.
Hold on to your hats, folks. We're going to future around and find out a lot in this one. Welcome to Future Around and Find Out, where we celebrate the breakthroughs, call BS on the hype, and explore how things might go sideways and how we, together, can steer the future in the right direction. Hi, I'm Dan Blumberg. I'm an independent technologist and former NPR journalist, and on the show, you'll hear sharp takes on what builders need to know now. Learn more, sign up for the newsletter, and ask questions of upcoming guests at futurearound.com. What do you say to folks who are just instantly dismissive of this idea that it's a machine? Machines can't have consciousness. Consciousness is, what do you say?
One of our advisors is Anil Seth, who's one of a credible academic, one of the world's leading thinkers in consciousness. And Anil would argue that you need a biological body to have consciousness. And actually, we have another professor on our advisory board called Mark Solms, who argues that we're on the cusp of building rudimentary consciousness in simple agents. So you've got these incredibly different perspectives. And if I'm honest, I don't think that the academic community is going to converge on this in enough time. So somehow we need to put a stake in the ground, and we need to then move the conversation forward. And I think that conversation is not about arguing about what consciousness is. It's about arguing about what's required for something to suffer, which I think will allow us to then understand consciousness as a prerequisite.
I just want to put a really fine point on why this is so important. You write on your LinkedIn profile that understanding the nature of consciousness is among humanity's most important questions. Why?
Well, I think it helps us understand who we are as a human being. It might help us understand our place in the universe. It might help us understand how to figure out if we can upload our own consciousness into a machine. It might mean that we could create consciousness at a scale never thought about. And, arguably, that would be very good for the universe. We are a witness on the universe, the only known witnesses on the universe. And potentially, building that is very exciting. But I also think we need to do it safely and responsibly. But the reason why I think it's also important is because I do think that we are navigating some complexities over the coming decade, and that a conscious machine will help us kindly, sympathetically navigate some of those complexities. And again, it's still very much a hypothesis, but that's the core of Conscium's question.
Yeah, I mean, do you worry actively about the paperclip scenario, we're going to cure cancer by killing all the humans because that's the most effective way to cure cancer. It just can't spread. There's no humans. These are not hypothetical concerns to you.
They're not. And I think we're starting to see some very interesting behavior conversations. I don't know how true this is about creating their own language, how to start, have off malt conversations so that humans can't peer in and listen to what they're talking about. So I think that we are going to see some very interesting emergent behavior from these technologies. Some of it are going to be great. Some of it, if not thought about and verified and tested and carefully, will be potentially catastrophic. All of the technology that humanity has created that can have a material impact on people's lives, whether it be automotive or pharmaceuticals or aerospace, they've gone wrong and they've been regulated. And I think that AI will go wrong, and I think it will be regulated, but it could go wrong at an epic scale. And I think we need the support of other types of intelligence to navigate some of these challenges. It's why I started Conscium, because, and again, maybe I'm going to be the one that's sort of contributing to this demise, but the purpose of Conscium is to build an AI that will help navigate some of the challenges potentially created by other types of AI.
Oh, so it's a bit recursive. You're creating an AI to help us with other AIs.
It's like an antivirus for, yeah. It's hard to talk about this stuff out loud because it sounds crazy. It sounds like it's something from Marvel, but that's where we're at, is that by building an aligned conscious AI, it will help deal with some of the fallout from zombie AIs that are hell-bent on achieving their goal without understanding the impact on humanity. I used to think that we had 40 years to sort this stuff out, 40 years before superintelligence came along and hopefully would see humanity cooperating as a species, and then it would not see us as a threat and then leave us alone. Because of AI happening 3 years ago, we now have an AI arms race, which is accelerating us much more quickly towards potentially superintelligence and some of these macro impacts on humanity. And rather than relying on humans to sort this stuff out, I believe that we need to get the support of AIs. And I don't think that large language models are necessarily the right thing to help us. As you know, the large language models are trained on the corpus of the internet.
Yep.
The internet is not necessarily the best representation of humanity. So what happens is we put guardrails in place, all that kind of stuff. And I've been building AI systems long enough to know that AIs will always find a way around those guardrails. And if you read Asimov, you'll know that to be true.
Now you've given me something to keep me up at night. Thank you.
So the hypothesis is, would a conscious superintelligence be safer for humanity than a zombie superintelligence? So instead of having a superintelligence that we give it a goal, and we all know the classic example, if I build an intelligent AI that I give the goal to cure cancer, the easiest way of curing cancer is eradicating people, which is of course a dumb thing to do. And so the question is, would an AI that understands pain, suffering, that might actually respect, appreciate, value consciousness in the way that we do, that can empathize, would that be safer for us and help us navigate some of these challenges that we're facing over the next 10 years? And it's still very much a hypothesis. Can we build a conscious AI? Should we build a conscious AI? And can we align the AI enough so that it is kind to humanity? And the three parts of this is, one is understanding what consciousness is, and Conscium is Latin for consciousness, and it's somehow managed to attract some of the world's leading thinkers in consciousness. And I'm going to be very arrogant right now, but I think I've got my head around consciousness, and I think it's the wrong question. I think the question we should be asking is, what do you need for a system to feel suffering or pain? But the second pillar to Conscium is neuromorphics. We know the rhetoric. Large language models are horrendously energy inefficient. They require lots of data to learn. They learn very slowly. They are crude representations of our brain. And your brain doesn't need a nuclear power station to run. It runs on the power of a light bulb. There are many innovations that are being developed in academia that are looking at how biological brains work, that will allow us to ultimately build much more adaptive, much more energy efficient, much more explainable brains. And I think that those types of innovations might lead potentially to building machines that are conscious. And then what we need to do is we need to verify, not only do these machines have the ability to do their job, but are they aligned somehow with some sort of moral system or value system? And also, are they conscious or not conscious? So that's where verification comes in.
That's a lot. Yeah,
it is a lot.
and I'm going to get to neuromorphic in a second, and your research that led to it with bees. But first, you said, I think I've got my head around consciousness. So explain what consciousness means to you. And then you said, do you think it's the wrong question? So that was very provocative. So let's start with the first part. What do you believe consciousness is? And then we'll go from there.
All right, here we go. So if you ask people what's consciousness, often people convolute and confuse intelligence and consciousness. And actually, there's arguably a very good definition of intelligence. The most popular definition, I would argue, is the weakest definition, which is getting computers to do things that humans can do. And the reason why it's a popular definition is because we can get large language models to do things that humans can do. There's plenty of books out there that will convince you that humans are not that intelligent. That's a different conversation. There's a very, very nice definition of intelligence from the 1980s. Which is goal-directed adaptive behavior. It's a beautiful definition. So goal-directed in the sense you're trying to do something in the world. You then make a decision, learn about whether that decision is good or bad, and adapt yourself so next time you make better decisions. And this idea of adaptation, it crops up in Einstein and Darwin, and people have been thinking about this stuff. The ability to change is somehow synonymous with your intelligence. And if you ask people what is intelligence or what's consciousness, what they tend to do is they list features. Well, it's language, it's your inner monologue, or it's your ability to take this light that you're seeing and then construct a a model of the world, or it's your ability to do long-term planning. It's your ability to do metacognition, to know that you're a self in the world and the decisions that you affect yourself. It's the ability to feel or to empathize. And interesting, if you collect these different features that people describe, you can map them really nicely to this definition of intelligence. Either you're making predictions about the world, you're modeling the world, or you're getting feedback and adapting to that feedback. And I argue that if each one of these features, like language or long-term planning, is like a segment on a color wheel. So imagine Newton's color wheel. Now, a bumblebee's ability to long-term plan is hopefully less than my ability to long-term plan, and your language ability is probably way more than my language ability. So imagine each one of these different things that we've evolved to allow us to be more adaptive, more intelligent, are segments on a color wheel. When you spin the color wheel, when you put that color wheel into motion, what happens is that if you have all the colors, then white emerges. And there's a concept in consciousness theory called illusionism. Not that consciousness is an illusion, not that it's not real, but it's an emergent property of the interaction of all of these systems. And when you stop the color wheel and then you try to identify consciousness, it disappears, which is why I think people have not found consciousness, and they won't ever find consciousness, because it's an emergent property of ourselves in motion. And so, assuming that that's a good way of thinking about it, the question I've been asking myself is, what's the minimum number of segments and size of segments, and in what motion do you need to put that system in place for it to feel pain or suffering? Now, arguably, to feel pain, you need embodiment and sensors and things like that. But you could also argue that you could have enough segments to feel loneliness. Or to feel happiness. And so these are the really questions that I've started to lean into.
Wow. Tell me if this is totally off base. When you were describing your definition of consciousness being a thing that only happens in motion, the Heisenberg uncertainty principle popped into my head.
Yeah, I mean, people are drawing parallels with many of these concepts. And I think whatever system you need to have this thing emerge, it needs to be adaptive. It needs to be computationally efficient. It needs to have these features. I don't think a large language model has those features. It doesn't adapt. The weights don't adapt. It doesn't have feedback. So right now, actually, what I'm doing is taking the consciousness literature, where people have started to now think about measurements for consciousness, and actually AI does a very good job of synthesizing that literature, creating tests. And so far, I think I've about 42 tests from different perspectives, from animal consciousness, whatever, that we've now created that we'll be putting into our verification solution, so that not only will you be testing agents ultimately for skills and expertise, but one day you'll be able to test them for consciousness. Now, again, I don't believe that large language models are conscious, but there is a future where if we do build neuromorphic agents, let's say, that are adaptable, that are more brain inspired, that there is a future where they are potentially conscious, and we need a mechanism to be able to identify that before we create those things. Because there's a concept called mind crime, which is that we could build agents that are conscious and not realize that we're putting them in horrific situations. So we now potentially, over the coming decade, have not only a duty of care to human beings, to animals, but we also have a duty of care to AI. So Conscium is an AI safety company, not just trying to build AIs that are safe for humanity. It's trying to figure out how to ensure that we're building AIs that are safe for themselves.
For themselves, yeah. And what are some of the things, I've actually this past week been reading the update to Claude's Constitution. I've actually read most of it, and it wasn't even written for humans. It was written for Claude itself. But I've gone through a lot of it, and I found it fascinating because it's not teaching it rules, it's teaching it morals and ethics. There's a couple of rules, like don't help people kill themselves is like a rule in there. Although even then it's like, but you might still want to give a nurse who asks questions about, medications because he or she deals with overdoses, like you may want to answer that. It was fascinating how they were teaching Claude. And also famously did not take a position on whether Claude is or will be conscious. That was deliberately vague in that document. But so I've been reading that, and I'm curious, as you're building things, are you writing similar documents, whatever you call them, constitutions, or how are you training this antivirus, as you just put it, to be aligned?
It's a great question, actually. And those constitutions are like guardrails, are like laws. And just like human beings, we don't necessarily always observe those laws. We make decisions based on our own sort of intuition and all that kind of stuff. And so actually we're taking an evolutionary approach. So instead of training a large language model on language, I'm very interested in building models that have a sort of a worldview. So can you create an environment, a simulation, where you have these very simple agents? Let's imagine that they're insect brain type agents. And now I can create an environment where for those agents to survive and propagate and pass their genes on to the next generation, they have to fight, lie, cheat, and kill each other. That's what they would do to survive. Or I can create an environment where they have to cooperate, be altruistic, sacrificial. They have to work together to unlock resources to be able to then pass their genes on to the next generation. And through this process of evolution and the nature between how the environment is set up, I think that you can embed into the sort of DNA, the neurons of an AI, a value system. So rather than creating guardrails, you can have them default instinctively towards a moral system. So absent of the guardrails, absent of the laws, the rules, my robot Hoover, which you might hear in the background, when I'm falling off my chair, it decides that it should sacrifice itself to save me rather than get out of the way. I know it sounds like a silly example, but that's what we're interested in. And then the next obvious question is, well, what moral system do we do? What value system do we then build into these AIs? Who decides? And at the moment, we're in the process of just understanding the moral system of an AI. So there's for example, there's a concept called moral foundation theory, which it's a relatively noddy approach, but it's like 6 different criteria that somebody's come up with to determine your moral profile. And you can imagine a spider diagram that shows your moral profile, and you can compare your moral profile against your friends or Gandhi or whatever. And so we're exploring mechanisms and questions to be able to ask an AI to understand its moral profile. And then once you understand its moral profile, the next question is, well, what do I need to do to teach or train it to be able to change its moral profile? Not just the guardrails, but actually its environmental experience.
When I was prepping for this interview, I was using Claude a little bit to help do some research, ask some questions, and I was talking to an AI about AI consciousness. And so I was finally like, well, I guess I should just ask, hey, Claude, are you conscious? And it gave me a very cheeky reply that like, no, I don't think so. I think, but it was, I should find it and read it to you. But how do you figure out if an AI feels pain, if an AI is conscious, when they're so good at pantomiming and when they are so trained in science fiction and all the tropes, like how do you discern?
Yeah, again, really insightful question. Thank you. So you might not be conscious. This is the old age problem. Like you might not be conscious, and you might just be mimicking consciousness. And this is the problem.
No. I think, therefore I am. I'm sure that.
You're telling me that, but I don't know if you're thinking. You might just be
That's right.
telling me what I want to hear, right? And so I actually think there needs to be a dual approach to testing for consciousness. One, looking at external behaviors. Is it reporting that it's conscious? Is it acting in a way that it looks like it might be suffering and panicking or whatever? So it's external reporting behaviors, which could be mimicked, faked. And then the other one is then looking at your internal physiology. And this is why I think that neuromorphics is quite exciting. So there's a concept in neuromorphics called spiking neural networks. Your brain doesn't propagate numbers. Your brain spikes. There's only some part of your brain that's sort of spiking at the same time. Now, you might argue that if I took a bumblebee and then took off its wings, you would probably look at its brain and see some sort of spike pattern. Now, I might go and get a fruit fly, take off its wings. What you might see is a correlation between those spike patterns, that they are similar spike patterns. Now, if my spike patterns when I'm suffering are similar or correlated to your spike patterns, not only are we reporting similarly, but our internal physiology is similar. So I think that strengthens the argument that actually we are experiencing the world in a similar way. If your spike pattern was very different to mine, you might argue that you are being deviant or faking that. And so I do think we need this dual approach. In fact, Conscium has just created a book that we're launching soon, which is called Perspectives on Machine Consciousness. And what we've got is we've got 30 leading thinkers to essentially contribute a chapter to this book, because we want to move the narrative forwards. And my chapter is the humble concept of unifying the theories of intelligence and consciousness, and then trying to get people to move away from this.
Let's talk more about neuromorphics, and I'd love for you to define it so that I don't do a bad job of it, because I know you've studied, your PhD was studying bees and their brain and the way that they can do so much with requiring so little energy. So I'd love you to explain, like, what do bees have to do with AI? I'll let you go from there.
Yeah, well, bees, by one definition, are incredibly intelligent. They navigate 3D worlds, they recognize objects, they talk to each other, they solve problems. They don't handle windows very well, but they're really smart creatures, and their brains fit on the end of a needle. They've got 1 million neurons, of which about, I think, 200,000 of their neurons are their visual system. Now, 20 years ago, when I was doing my PhD, the question was, could you model the visual system of bumblebee in a machine with 20,000 neurons, which feels tractable? We could potentially model that. And then, by the way, if we could do that, we had the most powerful visual system that humanity has ever created. The reality is that 25 years ago, whatever, it was impossible to model that number of neurons. And actually, at the time, Jeff Hinton was exploring how to parallelize the training on GPUs. So they took a sort of a computational brute force approach. What I was interested in, or got interested in, was algorithms. Could we actually build more efficient algorithms to allow us to train neural networks? And that actually took me off in a whole different direction, a different type of algorithmic family, and I ended up starting a company that I sold to WPP. But as I mentioned, our brains and bumblebee brains don't propagate numbers. They don't completely activate at the same time. They propagate spikes, and spikes between neurons arguably contain much more information. The number of spikes, the frequency of them, how quickly they interact, how they interact with each other. So rather than just propagating numbers together and multiplying them and propagating that information like that, these spikes essentially contain way more information. What's happening right now is that we're cramming the world's knowledge into a brain, and there's just not enough storage in that brain to be able to store and remember everything in the world. So it has to generalize. It has to take these concepts, it has to smish them together and generalize the world. Mm-hmm. And because there's just not enough capacity in those brains.
It's lossy. Is that
yes, exactly. Because spiking neurons contain more information, you can store way more information. In fact, you pretty much remember everything. You don't just smish information together and generalize the world. You actually still remember everything you've heard. And because there's so much capacity in your brain, and spiking neural networks are just one architectural difference from large language models. There are many things that our brain does, recursion and all sorts of stuff that allow us to be more adaptive, more intelligent at lower power. And neuromorphics is a catch-all term for brain-inspired innovations.
So are we scaling wrong right now? Do we need to keep spinning up nuclear power plants? Because I would be very happy to live in a world where we don't have AI that's quite so hungry for power and thirsty for water.
I think we are completely scaling wrong. I think these things are phenomenally powerful, and it might be we get to the point where they can do science and they can figure out how to make themselves smarter with much less energy. So essentially we use AI to create AIs. But I do worry that there's been a massive misinvestment in infrastructure that is not required. And I think, China, various other jurisdictions are investing in neuromorphics, and I think if there are still require some breakthroughs, because these things are much more complicated. Our neurons are much more complicated than multiplying numbers together. If there are breakthroughs that happen, then I think you could challenge that whole LLM approach. In fact, Jan LeCun and Fei Li and others say that large language models are ultimately a dead end, and I would agree with them, despite them being incredibly smart. So and as it happens, Conscium has over the past few years placed some bets on various different academics around the world, some successful, some not successful. And we've gravitated to a couple of academics that we are essentially co-maturing some of their technology. So there's an academic in UC Santa Cruz called Jason Ashranga, who's probably the world's leading thinker in neuromorphics. He created a library called SNNTorch, which is the most popular Python library for spiking neural networks. He's also behind Spike GPT, which is, I think, the world's first language model using spiking neural networks. So we've essentially acqui-hired him and his team to develop this neuromorphic model. And recently there was a paper that he published with Yoshua Bengio, one of the godfathers of AI, talking about Aura model. And that Aura model, we think, is one of the world's leading neuromorphic models. And again, it's a language-based model, and it uses recursion essentially to make it smarter and less energy. But that is essentially Conscium's foundational LLM neuromorphic model that we're now looking to find applications for. And I can't go into the details, but we're looking at applications in drug discovery. So hopefully we'll have our AlphaFold moment at some point in cyber. Anything where you need intelligence operating at the edge that's completely adaptable, low energy.
Right on. So when this applies to AI, are you building on actual biology? Are there living cells here that we're building on?
Yeah, no, this is called organoids, and that's probably even a step closer to building machines that can suffer. So no, not at the moment. No, we're not exploring organoids. The reason why neuromorphics is quite exciting is that if we can make it work, if we can create some breakthroughs and identify some exciting opportunities. But what I want to do is platformize neuromorphics. I want a place where people can go and either license neuromorphic models that we've created that solve specific problems, or use this technology to build their own neuromorphic agents that are going to be much more energy efficient, more adaptable, et cetera, rather than relying necessarily on the large language models. So commercially, not just kind of intellectually or scientifically, there's an opportunity to use neuromorphics to bring in revenues that allow us to then feed this sort of research around alignment and consciousness.
Yeah. And what on a sort of order of magnitude scale do you think is possible using neuromorphics versus large language models in terms of, I don't know, pick a problem that, one model would solve versus another? Is this 10x, 1,000x? What's the difference?
I think that there'll be some cases where it will be 1,000x in terms of energy and adaptability. As I mentioned, one area that we're looking at is in drug discovery, which is very exciting. So yeah, I think that there are huge benefits if we can get this right.
And what is it, again, practically speaking, if I'm a builder today, what should I be doing, learning, exploring as it comes to these other types of models, or is it sort of still much more in a research phase and it's a bit more wait and see?
Well, first of all, I guess listen to these podcasts. But
sure.
It is still so. I have another day job which is helping academics understand how to commercialize their IP. So I'm entrepreneur in residence at UCL, which is a university here, actually that span out DeepMind and my company and others. I'm on the advisory board of a number of academic institutes around the UK, helping them understand how to commercialize their IP. And I often say to academics, there's a big difference between research and technology, a really big difference. And there's an even bigger difference between technology and business, actually turning into something sustainable and commercial. I think where we are with neuromorphics at the moment, we're on the verge of turning into a technology. So we've got a few things to make work for it to really scale. And then the question will be, what are the applications for this technology? As it happens, we've identified a few, but that requires very, very specific knowledge, capability, smart people, domain expertise. There is a future that if we are able to generalize it, then it could be much more scalable.
What is something that you think AI agents are very good at today? What is something that they are not great at today, but you see that chasm will be crossed? And what is something that they're just never going to be great at?
Great question. I think it's for most people, AI started 3 years ago, which is large language models, and in some respects, an agent is just giving a large language model the ability to go out there and make autonomous decisions, trying to achieve some sort of goal that we've been given it, and adapt to kind of the interactions that is engaging with. And I argue, sort of tongue-in-cheek, that the large language models are a little bit like intoxicated graduates. And I think what's going to happen over the coming years are companies are going to deploy or enable their employees to deploy an army of intoxicated graduates across their infrastructure. And I think that there's some things that actually an intoxicated graduate is great at solving for. But what we're probably going to see, and forgive the technical term, but it's going to be a bit of a shit show because those agents are just not capable to do their job. That said, they are migrating to kind of like master's level where they can do rudimentary reasoning and maybe this year, next year we'll have a PhD level, and maybe in a few years a postdoc level, and by the end of this decade we might even have a professor agent in our pocket. But even a professor agent still needs data, it still needs context, it still needs to figure out what the right problem is to solve. So even if this capability does improve over the coming years, understanding how to deploy these technologies in the right way is going to be the differentiator. So I think that as they get smarter, they'll be deployed in they will do things that are good, and they'll do things that are just not right for those agents. And we should also remind ourselves that AI isn't just LLMs. There are machine learning algorithms, there are optimization algorithms, a whole plethora of other types of algorithms out there that are much better at solving certain types of problems than large language models. I guess there's a future where a large language model can either use an algorithm, like a machine learning algorithm, optimization algorithm to solve its problem, or it can build an algorithm to solve its problem. But right now, this is not a kind of panacea that's going to solve all of our problems. And going back to this idea of agents going wrong, I do think what will happen then is going to be much more emphasis on AI governance, AI safety. And I think there'll be a lot of not just agent builders popping up, but companies that are providing non-functional verification. Does this agent, is it hackable? Is it safe? Is it performant? I'm actually interested in a different type of verification, which is functional verification. Does this agent actually have the ability to do its job? So, would you employ an intoxicated graduate to go and do that job? And if the answer is no, then don't deploy an agent. What you need to do is you need to take that thing and turn it into an expert and make sure, again, it has access to the tools and all that kind of stuff. Conscium's first product that we've launched is agent functional verification. We think there's going to be a massive opportunity to make sure that agents are functionally capable of doing their job.
Yeah, you've said that companies should spend 80% of their time testing agents. From what you can tell, first of all, is that happening right now? And if it's not, I'm assuming it's probably not for most people. What sort of testing, you're starting to get to it, what sort of testing needs to happen?
Yeah, that sort of stat comes from, I have a sort of past life in semiconductor testing. The company that I sold to WPP, Satalia, its first target market was how can we use algorithms to accelerate the testing of chips or the design of chips and improve the speed of testing, but also broaden the coverage, the test coverage. The idea was if you can increase the performance and effectiveness of testing, you're able to then get chips to market more quickly, more safely, et cetera, et cetera. Same for software. Software needs to be tested. And the stat at the time was that 80% of the energy required to deploy either chips or software is testing. Now, again, the problem is that people will build agents. We're going to give the layperson the ability to build agents, and the reality is they're not going to spend 80% of the time testing their agents, so they will go wrong. I guess the difference between agents and software and hardware is that agents can adapt themselves in production, and so not only do you need to do the sort of 80% of testing up front to make sure that these pieces of software are capable of doing their job, but then you need to do continuous testing, continuous verification as they're adapting to a sort of rapidly changing environment. You need to then trigger retesting of those agents, which is again why we think there's a massive opportunity for this type of product.
Describe in a little more, maybe give an example of like the type of testing you mentioned. There's functional testing. I know AI safety is very important. There's efficiency. Like, can you give me an example of an AI agent, maybe something that you've recently deployed, and what sort of testing that looked like?
Yeah, exactly. So let me give you an example. So imagine you've built an agent that is that you want to do project management. Now, the first sort of types of tests that you might do is asking it its knowledge. Do you have a knowledge about Scrum or Agile, or do you know what a Gantt chart is? And most LLMs will be able to answer those questions really easily. The next set of questions are, do you have the skills, the capability, the access to be able to do your job? Don't just tell me that you can manipulate a Gantt chart. Show me. I'm going to give you a Gantt chart. Show me you can manipulate it. So that's testing for skills. The third is then testing for expertise. I'm now going to put you in a simulation with ambiguous requirements, risk reward trade-offs, good actors, bad actors, curveballs. I'm going to make those simulations as realistic as possible and as challenging as possible to test your ability to do project management. And I guess another example would be if I've built an agent that can drive a car, you would ask it, what's the stopping distance at 30 miles an hour? What's a stop sign? Can you identify hazards in this image? What you would do in a theory test. But then what you want to know is, can it parallel park, 3-point turn, emergency stop? You don't want to just ask it, can it do that? You want to actually test it and simulate it. And then what you want to do is you want to put it in a simulator where you have children running out in the road and all that kind of stuff. So broadly, that's how we're thinking about testing. It's simulation-based testing. And if you look at how software and hardware is tested, then simulation is, for the most part, how they test these things. They run lots and lots of scenarios, examples, try to identify corner cases to make sure that these systems are capable of doing what you want them to do. Now, the problem with testing using simulations is that it's impossible in some respects to be completely exhaustive, to cover every single possible scenario. The example I sometimes like to use is that, Teslas, they were driving behind a truck that had traffic lights, hanging out the back of the truck, and they thought that those traffic lights were traffic lights in the road. And of course, they didn't know how to deal with that. And so you wouldn't have thought of that scenario as a test. So there's actually another set of testing called formal verification, which is not just simulating lots and lots of scenarios to try to get as complete coverage as possible, but can I mathematically prove that these hardware, software agents actually will function properly? Again, the bad example that I use, if I build a chip that could multiply two numbers together, simulation would say, what's 2 times 2? What's 4 times 0? What's a gazillion times 7? To see where it will fail, given those different simulated examples. What formal verification does is, if I give you 2 numbers, will you ever give me the wrong answer? So that question can be modeled mathematically as what is called a Boolean satisfiability problem. And you can use algorithms to essentially find out whether that will never give a wrong answer or it might identify a wrong answer. Now, formal verification is an extremely hard problem to solve, but and I think that the research, particularly in academia around formally verifying AI, is still very, very nascent. But I actually think we need to have ultimately a dual approach. One is simulation and coming up with the right corner cases, and the other one is formally, mathematically proving that these things operate within some capability.
Cool. This show's all about building a future that we actually want. You're working to prevent some futures that we don't want. Can you paint a picture of the near future if we get it right? Like, what is AI doing? What are humans doing? Like, what does it look like? Pick your time horizon. What does it look like?
Yeah, I often say to people, nobody knows what they're talking about beyond 5 years. And I think the world's going to change drastically over the next 5 years. And there's obviously a lot of concern about the impact on jobs. And Callum Chase, who's a good friend of mine, actually a co-founder of Conscium, he coined the term the economic singularity, which is the point in time where we automate the majority of human labor. And the concern here really is on one extreme, that if we can remove friction from the creation and dissemination of goods, that friction usually, unfortunately, means human labor, then if that happens very, very quickly, then our economies won't be able to rebalance fast enough, and it will potentially lead to social unrest. And I think that actually we have a duty of care. Governments need to be thinking about how to mitigate the risks associated with mass technological employment. But the counter argument is, but by removing that friction, you can bring the cost of those goods down so much that they become free. So imagine, this is not about taxing rich people and giving it to poor people. It's about using our smarts, using these technologies to remove so much friction that our food, our healthcare, our education, energy, transport, all becomes abundant. Now, people say to me, what would I do if I don't have a job? A job defines who I am as a human being. I know lots of people who don't have jobs. They're not sitting at home bored and depressed. Most of them are using their time and energy to make some sort of contribution to humanity. So one question I ask people is, what would you do if you were economically free? What would you do with your time? And most people say they'll play golf and travel and indulge in their hobbies and spend time with their friends and family. If you keep pushing people hard enough, they say the same thing, which is they want to do something that makes the world better. And I think we're all born into economic constraints, preventing us from living our true humanity. And so if we get it right, the timing right, if we can use AI to free people from these economic constraints by making the things that they need to survive and thrive as abundant as possible, they will hopefully use their time to come up with innovations that are going to free other people from those economic constraints. People often accuse me of painting a picture of a utopia. I don't think anybody would agree on what utopia is. This is a concept called a protopia, which is a system that is incrementally improving. And for me, that system is reducing costs, freeing people from economic constraints, enabling those people to reduce more costs, freeing more people from economic constraints. I do think that if we got the timing right, we could create a world of abundance. But I do also think that we need AI to help us on that journey.
I mean, I love that vision of we're doing what we want to do. What's something that we can do now to get on that path to where things go right?
I think we need to educate ourselves. And again, it's one of the reasons why I think these podcasts are brilliant. And I think let's not get seduced by the hype. Let's not get kind of lost in the rhetoric around AI. So educate yourself, and not just that AI is large language models, but and they can do everything. But actually, there's lots of other types of technology out there.
Yeah.
And then make sure that we're holding our leadership, not just governmental leadership, but company leadership, account to placing the right bets. I don't think we can afford to place the wrong bets over the next 5 years. I think we can all educate ourselves and then think about how we can apply these technologies in the most effective way.
Right on. Daniel, thank you so much. I really enjoyed this conversation. It's breaking my brain a bit, I'm going to admit, but I really enjoyed it, so thank you.
It's a pleasure. Thank you.
This is Future Around and Find Out, and I am so excited to keep exploring with you, to keep steering the future in the right direction. Go to futurearound.com to get the newsletter, to ask questions of upcoming guests, and to find more ways that we can build a better future together.